we have a backup. And thanks for you on the call. Just want to introduce Matteo. He joined StreamNative. He's our CTO, and he'll be presenting today. Thank you, Matteo.
Thank you, Dan. So these are the monthly project updates. Like every month, we changed a bit the formats this month, but I would just go through what happened last month. We had the Pulsar Summit North America and now all the sessions and the keynotes are available on the YouTube channel, or if you go on the Pulsar Summit page as well, you can find all the sessions there, and as well, all the slide decks and the recording of the videos. We also did announce the Pulsar Summit Europe, so it will be held on the September 22nd, and the CFP is open. So please go ahead and submit your talk if you have any use case. It's mainly targeted for a European community, but any talks, any session are welcome. So if you weren't able to submit a talk for Pulsar Summit North America, please submit it for Pulsar Summit Europe, since it's virtual, so there's no travel involved. And releases. So the big release for last month was the Pulsar 2.8. That was like a long cycle, but we wanted to make sure that we had transactions included, and that transaction was really ready for GA. The transaction was the biggest feature. It was not the only one. There were like tons of other features from into 2.8, things like the exclusive producer, or like a package management for the functions to handle the function jars, and a new client memory limits to make the configuration much easier than before. And we started the work on the pluggable metadata interface. This is a work that is ongoing, and so it's still going on, and will get completed in 2.9. But the first bases have been started in 2.8, and other things like we have broker metadata that enables other uses to implement things like KOP in a much better way, and the streaming dispatcher, and also like user-facing feature to get the applied topic policy, so that you can see what are for each topic. You can probe which policies are getting applied to your topic, because they're based on the hierarchy of all the possible places that you can apply policies at the namespace level, at the broker level, and so on. So yes, this was the biggest release. It was announced just before the Pulsar Summit. But this month we're going to talk about the biggest feature, so the transactional semantics in Pulsar. Let's first start to define what are the semantics. These are the typical semantics that you have messaging. You have at most once, least once, and exactly once. So everyone knows the phrase, but the definition can be a bit more tricky. So we had the at most once and the at least once since the beginning, and we also had exactly once. It was introduced in 1.20, so it was like a few years ago. It was like PHP 6 was one of the first proposals that was discussed, and basically this is like exactly once achieved through message duplication. So you have the guarantee that you can achieve the duplication, and this is all handled by Pulsar client library collaborating with brokers. In presence of any kind of failures, it will guarantee that you can deduplicate your messages. Let's see how it works. So if you look at when you send a message, a client will send a message to the broker will store it in a log, and so it gets appended to the log, and the log it is an immutable. So you get new M1 that gets appended, and you get an acknowledgement back, and that acknowledgement makes to the producer. Another producer say, okay, my message was produced correctly, so I can move on. And it sends another message. It sends the message gets appended to the log, and the act goes back, but now something happens. So the producer never sees the log, the acknowledgement. So the producer cannot cannot tell whether the message was produced or not. So now you have to make a choice here, and the choice is either I don't publish again, and in which case we have so let's first see the at least once is that in presence of failure I will resend the message, and this is the default behavior in Pulsar. The client library will always try to resend within a certain timeout, unless you are on a non-persistent topic. But when you resend the message, what happens is that it gets appended again. So now you have a duplicate here. The other option, so these duplicates are introduced because the failures can be in the broker, in the client library, and or in storage. So these requests basically are getting repeated. This is a safe choice, but it gets duplicates. The other choice, the risk choice, is at most once. So you get a failure, you don't know whether message 2 was persisted or not, but we skip it. So we don't get a duplicate, but we may have lost message 2 if it was not added to the log, and that we don't know. But really, people want to say, I want to have exactly once. I don't want to have duplicates. I don't want to lose data. The duplication can achieve that, although it is a bit tricky to use for the user, because it involves a bit more active participation from the application as well. So if you look at message duplication, essentially we have an idempotent producer. I have a producer that it is able to say that if I publish message twice, it is able to recognize that message is the same. And on the consumer side, we also need to basically use not the regular consumer interface, but we have to use the more low-level reader plus checkpoints. So I have to store my message ID somewhere in my state and then resume the consumption from that point on. So you can achieve end-to-end exactly once, but it really requires some involvement from the application perspective. And the way it works is that there is a producer name. So each producer, it is struct, and each message has a sequence ID. So the producer name plus the sequence ID, it is a unique identifier. And the sequence ID is a counter, essentially, and it has to be monotonically increasing. So it can have skips, but it really needs to be increasing, because we don't keep the entire state, all the messages, but instead we just rely on the fact that if we see a message with a lower sequence ID, that it has to be a duplicate, and therefore it can be discarded. So the implementation is actually is easy, is simple on the idea, because we just need to maintain a map and from a producer name and the high sequence ID that you have seen. The tricky part is really to make sure that this map we can consult, we can check it very quickly, and at the same time we want that map has to be persistent and associated with the log. So essentially the whole internal implementation is that there is a cursor, and that cursor is associated with a position and also with a map. And with that, basically we have a hash map in memory that is backed by the log. So we have a hash map in memory, but we can reconstruct it after a crash. So after a crash, we can recover from the topic and reconstruct the same exact hash map. And that hash map, it is used to do the check on the sequence ID, so that we can detect the duplicates. So when we have these exactly once, basically we have this message 1, we append it, and with the sequence ID 1, then we have appended with a message 2 with sequence ID 2, and when we don't get the acknowledgement back from message 2, then the producer can send it again. The point here is that it is sending message 2 with the same sequence ID. Therefore, we can detect that this message 2, without checking the content of the message, we just check the sequence ID. So sequence ID 2 is already in the log. Therefore, we can discard this second attempt of sending message 2. In this case, we detect the duplicate. We tell the producer, your message is persisted because it was already persisted. So we get the positive back, and the producer it is happy and can move on. And in the log, we just have one copy. Enable the duplication, it is easy. You just have to basically enable it on your namespace. That will basically all the topic in that namespace will automatically have the duplication. You should set a producer name if you want to have the duplication across different sessions of a producer. So you start a producer. If you don't specify a name, we get a random name. So if you start a new one, we'll have a different name. So if you want to identify that this producer is the same as a session before, you can specify the same name. And you can specify the increasing the sequence ID. Again, if you don't specify a sequence ID gets attached, but it is only valid within a single session. So if you want to restart your producer and start from a specific point, you should specify explicitly your sequence ID. And this is what kind of like makes it a bit difficult on the application, because you have to kind of think about these things. The other thing is on the consumer. So consumer basically you get message from the topic, right? But to have really the exactly ones, you should basically specify, I want to read from this message. And to do that, you have to store that message ID in your state. So if you're running like a Think pipeline or a Spark job, then you have to basically know that I want to consume from this message on. And therefore, like the block will start from that message. And since there is no duplicates in the log, then you get message twice, only once. Again, the only once is related to the final state, because if your consumer crashes, it will come back and it will restart from the last checkpoint. The important part here is that the effect of processing the message, it is only stored once. So you may receive message twice because your producer crashes, but you will apply the transformation only once at the end. So the limitation here is that this is basically meant to be on a single partition, and because each partition has its own sequence IDs, you can do some hacking around by using the same producer name across multiple partitions and using the same sequence. It is really a bit tricky to get it to work, and also it is not really atomic across multiple partitions. So you cannot say that I want to publish atomically to two partitions, and either I succeed in both or I fail in both. So there is no atomicity across partition. And the other thing is that there is no atomicity on the consumer side. That's why we have to use the reader and do the checkpointing stuff, which works, but is really more complicated on the application. Therefore, like we have thought about like introducing this transactional API. And if you look at transaction, really the goals here is having a semantic that is much easier to reason about. This is what you are expecting in a database transaction. So you have atomic writes across multiple partitions and across multiple topics. And you have atomic acknowledgements across multiple topics. So you can consume one or more messages, do some processing, and publish one or more messages in different topics, and have these to be all within a single transaction, and either all succeed or all fail. And the other part here is that the consumers will only be allowed to see the committed messages. They will never see dirty, uncommitted data. So what does the API looks like, right? So this is like a typical, like, let's say that we are consuming from one topic, and we do this, and then we want to publish messages into different topics. So we have one consumer and two producers. So we receive a message, we do some processing. As part of this processing, we have two output messages into different topics. And therefore, we want to do like 3 operations and have them to be atomic. Here, the send a message of message 1, the send a message 2, and the acknowledgement of the original message. So the important part here is that without the transactional API, this will happen, but it will happen not atomically, because let's say that we have the input topic here, and then we have the 2 output topics. These topics are being served by different brokers. They have different logs. Therefore, like when you say acknowledge message, that gets applied to the cursor in that topic, but it is completely unrelated to the publishing on the first topic. So if we wrap this with the transactional API, it is really easy to achieve the atomicity. So we can receive a message, and then we can start a new transaction. So we start a transaction on the client, and we have a transaction object. With this transaction object, we can basically tie all these operations to the same transaction. So we publish a message by saying that this message belongs to this transaction, the same for message 2, and the same for the acknowledgement. So when we acknowledge, we specify the transaction, and this will get applied, and then we can commit the transaction. Only when we commit, these messages will become visible in their own topics, and the acknowledgement will be effective. If for any reason we fail, we have any failure in between, or we call explicitly abort the transaction, nothing will be visible. So, like if you look at the same, we have now we have some additional helpers here. We have a coordinator with transaction log, and we also have these transaction buffers. So the coordinator, essentially, it is the transaction manager. So it coordinates the committing, the creating the transaction, logging whatever happened on the transaction, which topics are involved, and so on, and rollback, either the commit or the rollback, and it is based on having the in-memory state plus the transaction log, and the transaction log it is a Pulsar topic as well. So there basically it is just like publishing on for one transaction would be on one partition of this transaction log. The other part is a transaction buffer. So this each topic that is using transactions will have an associated transaction buffer, and the buffer again it is based on having managed ledger, which is a log as well. So there is some in-memory index state, but all the stuff it is snapshot into ledgers, and so therefore it can be rebuilt from the buffer. So you have the index and you have the buffer. So this is basically where the transaction, the uncommitted transactions are data. It is stored before when it gets committed, and then they get moved into the real topic. And finally, there's the cursor. So the cursor will not have an additional transaction buffer, but whenever there is a state for an ACK, so when you do an acknowledgement that is part of a transaction, will have an ACK pending state. So this acknowledgement will stay in the pending state until the transaction it is committed. So therefore, if the transaction fails, that message will get replayed, because the broker will see that as pending. Therefore, it is not acknowledged yet. So let's see the execution flow of that transaction here. The first part, we say that we create a new transaction. So that will involve the client to be talking with the transaction coordinator. And so it will establish a new transaction. We have a unique ID, and then we tell the client that the transaction is created. The second step is that we can, for example, like send messages. So we can send message 1, send message 2, and these get added to transaction buffer for each topic, and it gets also added on the transaction coordinator, so that it knows that there was a publish on topic 1 and topic 2. And the final part of this example was the acknowledgement. So when we get the acknowledgement, we send the acknowledgement to the input topic, and this basically gets set into the cursor in the state. So this is the act pending for this message 0. And now the final part is the commit, right? So when we do the commit, what happens is that we talk with the coordinator, and we say that we are committing transaction 1. Therefore, now it is the job of the coordinator to go and tell the brokers that are involved in this transaction, in this case, broker 0 and broker 1, because they have the input topic and the output topic 1 and 2. And it will basically tell them to commit that the parts of this transaction. So therefore, they will be copying the data from the transaction buffer into the output topic, and now the data is visible. And therefore, at this point, the consumer will be able to receive this message 1 and 2 on the output topics, and when the cursor will have the committed state on that message 0, that for the input topic. And finally, that state, once everyone has done the commit, then the coordinator will change the state to committed for the transaction, and eventually all this state will be able to get recycled later. So what happens on as a failure handling? So there can be failures again in every step here, right? So the first part is that we can have failures in creating a transaction. So in this case, you try to get new transactions, you cannot talk with the coordinator, it fails, it's okay. The transaction might stay open. For example, like if you don't get the acknowledgement of the transaction created, but that's a unique ID that's generated, so it won't interfere with any other transactions here. Another example of errors is that we create a new transactions, then we try to publish the messages, and one of them fails. For example, I succeed to message 2, and I fail on message 1. Now, what happens here is that we get an exception in the client because the publish fails, and this transaction will get aborted. What happens now is that when the transaction gets aborted, so nothing gets written into the output topic. Therefore, message 2 was never published because the transaction was never committed, and no consumer will see message 2. And we are guaranteed about that. The other failure here that we can get is that we have a failure in acknowledgement. So we send the acknowledgement to broker 0, this acknowledgement fails. Again, if this fails, we abort the transaction. So this message was never acknowledged, and also these messages will never get copied into the output topic. And now is that okay? We succeed into acknowledging and producing message 1 and message 2, and what about? And we tell the coordinator to commit. So if we tell to commit, and this operation succeeds from a client perspective, what happens here is that it will tell all the other components to also to commit their own portion, and this operation can fail. So but since we are committing, essentially the coordinator job, it is to retry this. So if there is a failure, it will retry to make sure that this transaction will succeed. So therefore, like if, for example, like if output topic 1 has already copied the message into the output topic, but for example, like message 2 was never copied into output topic 2, the coordinator will make sure that will retry to get this transaction to be to a stable state, because the data it is logged, it is there present in the transaction buffer. So eventually that we have to succeed. And same for the acknowledgement the coordinator will keep retrying. So just to summarize, the transaction is just making the messaging and streaming very easily and really for everyone, and it is really a step up from a usability perspective on starting from the exactly ones from the duplication that we had before. And I just did a quick introduction that just to leave a lot of time for questions. So I'm very happy to leave to open the floor for questions about transactions and implementation, or how it can be used, and what are the differences, and so on. So everyone, please raise your hand and don't be afraid to ask questions.
I unmuted it. I allowed everyone talking privilege also, so you can feel free to talk. Hugo, do you have a question?
Yeah, thank you for taking my question. I'd like to know which Pulsar client libraries support transactions in what languages.
Mm-hmm. Yes, good point. So at this point, we started with the Java client. The next step for 2.9 and maybe 2.10, we don't know yet is exactly when, but we want to add it also to the Go client and to the C++ client. Therefore, like once we add it to the C++, it will be also available in Python and Node.js as well. So the first part is to enable it on the C++ and Go.
Great, thank you.
And so it is there's a bit of work involved, but it's not the majority of stuff is on the server side. So all the heavy lifting was on the server side. So I want to expect that will have a lot of trouble into adding there into the existing CPP and Go clients. And also, like one of the goals for 2.9 is to have transactions enabled as really as a config options for the Pulsar functions. So Pulsar function really, if you look at it, is a consumer and a producer. So we just want to basically allow users to enable the transactional properties with a flag and with no code changes.
Any other questions? And Matteo, I'm sure you'll take questions on other topics as well, if anyone has.
Yeah, sure. So I'm very happy to talk on any other features on the 2.8.
The quiet bunch.
Yes, so I will just add that. So transactions are GA in 2.8 release, and so try today. And we also at StreamNative we also have the StreamNative Cloud, which is our full managed SaaS service, And we also like recently launched the StreamNative Platform, which is more like a self-managed enterprise software version offering of Pulsar. So these are kind of like two flavors that we offer. And I will finish up with saying that we are hiring. So if you want to work on these kind of features and really working on the internals of Pulsar, or I like in the service side, in the SaaS part, please reach out to me in Slack or email or whatever, and we are really looking for people that enjoy this kind of stuff to build.
Hugo, did I see you unmute? Did you want to say another? Did you have another question or?
It's a different topic. I'm interested in the boundary between software like Pulsar and service meshes. So I'm interested in understanding how you integrate a data ingestion layer built on Pulsar with a service mesh, which runs in Kubernetes and typically has an ingress point with perhaps gRPC, RPC. So how those two worlds come together? How do you see them coming together?
Sure. I have some kind of like mixed feelings about service meshes. That's so we've been using so so some companies I know like I worked as Splunk as well very recently, and we've been using service meshes in the form of Istio for most of the services internally, and as well for Pulsar deployment as well, which has pros and cons. The nice part is that if you're using a service mesh for all your microservices, for example, like you can also enable that for Pulsar and have your Pulsar deployment to be part of that mesh. What gives you there is that, for example, like it was nice. Also the box integration with TLS encryption with the certificate rotation and out of the box. It is really like a one-line change in the Istio configuration that in the YAML for the service, and that it will start the Istio sidecar, and that Istio's sidecar will provide the TLS termination with all the rotation and the certificates, and that really works like magic. In the Pulsar side, we don't really use gRPC or HTTP2 or anything like that. I mean, we have the admin API that uses HTTP, but really the data it goes through this to the Pulsar protocol, and there are multiple reasons for not using gRPC. That gRPC for data intensive stuff, it can be very expensive in terms of CPU serialization and so on. So it is a nice concept, but it has its own it has a lot of overhead in that sense. So the nice part is that you have everything out of the box, and your applications can use the existing service mesh for the authentication and all the stuff, and you can also use that for Pulsar. On the other hand, we've seen like a lot of some of the stuff becomes much more like the network debugging becomes much more difficult with Istio in between, because now you're seeing like all your IPs are like 127.0.0.1 instead of like being the real IPs of the pods. So now you have to play the detective to figure out who is connecting to, where and so on. And we also seen a bunch of issues with ZooKeeper. ZooKeeper was really not happy with when Istio was in between the leader election and so on. So that's a bunch of stuff that changing the networking from the direct connection to having a TCP proxy sometimes can lead to some surprises. For Pulsar proxy is fine. For ZooKeepers is a bit hit and miss there.
Good, thank you. That's very insightful.
Welcome.
Have you had a chance to work with Dapper, with the Dapper microservices framework, Dapper.io? Because it's also a framework for building microservices, and it has a component to interface to PubSub, including Pulsar and Kafka as well. But I'm interested in yeah.
The name is familiar, but I might be confusing with the. It also seems to be a common name, so I'm not sure. I'm thinking about the correct one. Which language is this framework on?
Well, originally it was written by Microsoft, and they open sourced it. They gave it to the CNCF, and the website is D as in dog, APR.io. So it's Dapper. Stands for Distributed Application Runtime. So DAPR.io. I found you could at first sight confuse it with service mesh, but it's not their sidecar is not intercepting every packet in and out of a pod. It is a site service with a bunch of capabilities from secret management and PubSub state, several other database capabilities, and then the PubSub has a interface to Pulsar.
That's nice. It's the first time I hear about this, so I will definitely check it out. And thank you for.
Sure. Yeah, I'm looking at that. You have a picture of a platform in Kubernetes with microservices that it's running, has an ingress, and you have applications running on it, microservice-based applications, and you have also inbound and outbound traffic, streaming traffic or PubSub traffic coming from the outside. And that boundary between those microservices built on pods and sidecars and maybe service meshes in this world of PubSub and streaming, maybe Flink somewhere in that picture. How do you? I'm interested in understanding what's the best way to build an efficient interface, if you will, between these two worlds.
Yeah, that makes sense. Yeah, I'll definitely check it out, but I can't comment on it because it's literally the first time I see it.
Well, we'll see that Go client with in transactions, adds another tool to the toolbox on how to build systems on Pulsar.
Yes,
that are friendlier to the Kubernetes world.
We just want, so we know that most of the stuff is in Go. That's why we also that was one of the reasons why we wrote the Go client library in as a native client, as opposed to having we used to have a wrapper on the C++, actually on this. A wrapper on the C that was a wrapper on C++, but we really wrote the library in native Go to make it more friendly with the Go applications, so that we have no other dependency than that. No C Go involved.
Great. Thank you, Matteo. Appreciate your feedback.
We're welcome. Thank you for the questions. Anyone else that has questions?
Doesn't look like it, Matteo. I think.
Okay. So thank you for for participating, and we'll do the same thing next month with a different feature and more updates. Thank you, everyone.
Yep. Thank you. Goodbye.
Thank you. Bye.